Hello, hi everyone, welcome back to the channel. So, continuing this video series where we are learning binary search algorithm and its various applications. In this video lecture, we'll be learning a very important concept, or we can say application of binary search, which is lower bound. And it is very important to learn these basic concepts because they will be used later in solving complex problems. And learning about lower bound and upper bound is very important to solve binary search problems. So this is one of the applications of binary search. So let's see the definition of what is lower bound. So a lower bound is basically defined as iterator pointing to the first element in the given range first to last. So in this function we pass this range first to last, which represents the position of the first and the last element in the array. Has a value That iterator has a value not less than k. That means, let's say the iterator is it, and this iterator must point to a value. So this iterator must point to a value which is not less than k. So that means it must be either greater than or equal to k. So that's what we want to find. For instance, let's say we have this function lower bound where we pass in the integer k. So this is integer k, which this is integer k, which is 6 here. We want to find the very first position of the integer where we find our element not less than 6. That means it it is either equal to 6 or it is greater than 6. So it can be equal to 6. So what is that position? So in this array we can see that the very first element which satisfies this constraint is this, because 6 is the first element in this sorted array which is either greater than or equal to 6. Okay, so the array that we are given is sorted in increasing order. So to perform the lower bound, to find the lower bound, we must have a sorted array. Fine. Only in that case we can perform our binary search. Fine. So let's see how we can solve this problem, how we can find this element, the first occurrence of this element, and how it is different from the regular binary search, how we can modify our binary search to solve this problem. So remember, in binary search we have two pointers. The first pointer is initialized with the very first integer of the array, while the second pointer is initialized with the last integer of the array. Then we find the middle element. So in that case, the middle el the middle the middle el the middle element would be 0 plus 7 by 2. That would give me 7 by 2, that is 3. That is the third element, 0 1 2 3. So this one, I'm pointing to this element after first iteration of the binary search. And now I know that. Now I compare this element with my element which I am searching for. So I compare it with 6, and I can see that this 6 which is present here in this array is basically greater than equals to the 6 which I have passed here. So it do satisfies this condition of lower bound. That means the first occurrence of the element which I am looking for must lie in this search space, that is from 0 till this point, and I discard this space. Fine. So R comes here. I again find the middle element. This position is position 3, and the middle element is 0 plus 3 by 2, that is 1. So 1 is this position, and here we have 5, and I can see that 5 does not satisfies this condition. This is false. This is returning me false. That means the target, or the first occurrence of element which is either greater than or equal to 6, lies in this search space, that is from this till this R, and this space is again discarded. Now in this I find the middle element. 1 plus 3 is 4. 4 divided by 2 is 2. That would give me this position, and here I again see that this 5 is basically not the target element. 5 is less than 6, so that means this is again discarded, and I reinitialize my left pointer with this position, and now L becomes equals to R. That means this is the only element we have in the range. So we have a range which contains exactly one element. So there is no way this element can't be the lower bound. It has to be the lower bound, or it has to be the very first element in the range first to last, which is not less than the value k, where k is 6 here. Fine. So that's all. That's just binary search. Whenever whenever we reduce our search space, that is, all we have to modify here is that whenever we reduce our search space, let's say the initial search space is L to R. Now after one iteration, I find that the element lies in this range, that is from left to middle. So here I update my answer because I reduce the search space from L to R to L to M only when the element at the middle index is greater than or equal to the element which I am passing. So the answer becomes M at this point. But then I have to look for the better answer because I am looking for the first occurrence, and that will lie in this range. So that's all. I will take another variable, let's call it answer variable, and whenever I reduce my search space from this search space LR to LM, I'm going to store this middle element into this answer array. Rest stays the same as we do in binary search. Fine, so I hope you got the idea. If you have any doubt in my explanation, then make sure to comment down. I will reply to the comment as soon as possible. So let's jump to the implementation part. So here's my implementation of lower bound where we are passing this value, and this value is basically the k which we explained in the previous slide. So we want to find the first occurrence in this nums array which is either greater than or equal to this value. So initialize two endpoints or boundary points, low and high. M basically represents the middle element, and answer is basically the lower bound. So this will store my lower bound. Let's say I don't find my lower bound in the given array. In that case, I have to return the index which is beyond the last element, and that index is n. So there is no such index as n, so we return by default the size of the array, or the index that is present after the last index of the array, because we are assuming that until the last index all the elements were smaller than this value. So probably the answer lies at the nth index, which is hypothetical. So then I run my binary search, and in this and that is usual binary search, I find the middle element. I check if the middle element in this array is greater than equals to the value. So if this condition is satisfied, this is the condition for the lower bound, and this can be my potential answer. So I store this middle point into the answer variable, and I reduce the search space from L to middle, or middle minus 1. While if this condition is not satisfied, then I reduce the search space from middle plus 1 to R. That means I will find my first occurrence in this range, because the current middle element is less than the value, so I have to go to the larger elements. Fine, in this fashion I will have my answer stored in this answer variable that I'm returning at the end of this function. Fine, so that's the lower bound function, which is very similar to binary search. All we have to do is to just use an extra variable and try to store the first occurrence of the value if present, or the first occurrence of the element which is just greater than this value. Fine, so let's jump to the time and space complexity. So since this is just a binary search, the time complexity would be log n, while the space complexity would be constant. Fine, so let's implement the solution in code. Okay, so this is the solution class in which we have a lower bound function. So let's calculate the size of this nums array where we want to find the lower bound. So let's define the boundary points in which we want to search for our lower bound. So L will be 0 while R would be n minus 1. Let's perform the binary search. Let's declare another variable answer which is going to store my which is going to store my lower bound, and it is initialized to n by default because that's the default value. So L is less than equals to R. Find the middle element, and if this middle element is basically greater than equals to the value, in that case I'm gonna update the answer to this, and the search space is reduced again. The search space is reduced here. The search space is reduced to the first half, that is R is reinitialized to m minus 1. Otherwise L is reinitialized to m plus 1. And at the end I will have my answer stored in this answer variable, and I will return my answer variable at the end of this lower bound function. So in this fashion I am implementing the lower bound. And this is the implementation in C++. Let's see the implementation in other languages. Okay, so this is the implementation in Java, and this is the implementation in Python language. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to my YouTube channel and share this series with your friends that others may benefit as well. And I will see you soon in my next video. Till then, take care, bye bye, and continue in the series binary search.